Hello class, so back again. This is lecture 3 for environmental chemistry, chapter 6. Yeah, my camera broke up the prior video into 2. I don't really know why, but anyhow, we're going to continue on. So we're going to talk about chemical formulas as conversion factors. All right, basically this is hopefully pretty straightforward. If we take a look at CH4, okay? So for every CH4 molecules, how many hydrogen molecules do you have? You have 4, okay? But I want us to think in terms of moles, okay? So for every 1 mole of CH4, how many moles of hydrogen are there? There's 4. So again, this can be written as a conversion factor, right? You can write it as moles of CH4 on top. Moles of H4 on the bottom, or vice versa. Again, depending upon what you're doing. We also have, for every 1 mole of CH4, we have 1 mole of carbon, correct? So again, it's just a conversion factor, okay? This information is in the chemical formula. It's there. You have to pick it out when you need it. Let's go take a look at another example. Let's say I have 1 mole of iron 2 nitrate, okay? What would be your conversion factor for this? For every 1 mole to oxygen, let's say. We're going to have for every 1 mole of iron 2 nitrate, what are we going to have? We're going to have 6 moles of oxygen, right? Because for every FeNO3, right, there's 3 oxygens here times 2, that's 6. So we get 6 moles of oxygen, all right? Or you could have 1 mole of Fe, NO3 2, iron 2 nitrate equals 2 moles of nitrogen. Or 1 mole of iron 2 nitrate equals 1 mole of Fe, of iron, right? So again, these chemical formulas are in front of your face. You just have to pick them out when you need them. Let's take a look at an example. We'll actually erase this once again, make some more room. How many moles of oxygen are in 3.7 moles of sulfuric acid, we'll say, okay? So we want to know moles of oxygen, right? Question mark, what are we going to do? We're going to go from moles of sulfuric acid to moles of oxygen using our chemical formula as a conversion factor. That's it. That's it. So, okay, so we have 3.7 moles of sulfuric acid. For every 1 mole of sulfuric acid, right, we're just thinking of 1 mole. How many moles of oxygen are there? Well, first of all, I want moles of sulfuric acid to cancel, right? So I'm going to put that into the denominator. Now, for every 1 mole of sulfuric acid, how many moles of oxygen will there be? There'll be 4, right? For every molecule of H2SO4, there's 4 atoms of oxygen. So for every 1 mole of sulfuric acid, there's 4 moles of oxygen. Moles of sulfuric acid cancels. Do your math. That would be 12, 14.8. But we only have 2 sig figs. So we end up with 15 moles of oxygen. Okay? So again, another conversion factor among the many we already have. I'll do another example before we move on to a more complicated problem. Let's take a look here. How about how many moles of, let's see here, I'll stick with oxygen, are in oops, messing up here. How many moles of oxygen are in 2.3 moles of magnesium nitrate? Sorry, goofing up here. So we want to know again, just like we did, moles of oxygen question mark, what am I going to do, or what are we going to do? We're going to go from moles of magnesium nitrate to moles of oxygen, again, using our conversion factor containing the chemical formula. All right, so again, we want moles of magnesium nitrate to cancel, right? So I'm going to put that down here. Now, for every 1 mole of magnesium nitrate, how many moles of oxygen are there? Well, there's 3 per nitrate, there's 2 of those, so 6 moles of oxygen. Correct? So moles of magnesium nitrate cancels, and then 2.3 times 6 is going to be what? 12, 13. Again, 13.8. We only have 2 sig figs, so we end up with 14 moles of oxygen is what we have. All right? Hopefully I explained that so it's understandable. Again, if not, I guess you're going to have to take a look in your book or again email me. Okay? But as always, we can make problems more complicated, and that's what we're going to do next. Because we're going to look at grams to grams. So let me use our book here. I'm using Skill Builder. .7 on page 180. Here it has determine the mass of oxygen in a 5.8 gram sample of sodium bicarbonate. In 5.8 grams of sodium bicarbonate, which is NaHCO3. Okay? Determine the grams of oxygen in 5.8 grams of sodium bicarbonate. So again, we want to know grams of oxygen, question mark. What are we going to do? We're going to go from grams of sodium bicarbonate to do this, right, we're going to have to go through moles, correct? Because we have to use the molar ratio of oxygen to sodium bicarbonate. So we have to go to moles from grams to moles for sodium bicarbonate. Once I'm in moles of sodium bicarbonate, what can I do? I can use my chemical formula as a conversion factor. Then I can go to moles of oxygen, correct? And then once I have moles of oxygen, I can use the molar mass of oxygen, and I can go to grams of oxygen. So molar mass of sodium bicarbonate conversion factor from the chemical formula, molar mass of oxygen. All right, so here, right, again, I'm going to use the molar mass, grams to moles. I want grams to cancel. So grams go in the denominator, moles go into the numerator. Be careful when you calculate that out, right? So we have sodium, which is 22.99, plus 1 hydrogen, 1.008, plus 1 carbon, 12.01, plus 3 oxygens, 3 times 16, and I'm getting 84.01 grams of sodium bicarbonate. Remember, 4 sig figs. So that means I'm here, right? Now I want to go to moles of oxygen. So again, I'm going to use the molar ratio in my chemical formula, right? Well, I want moles of sodium carbonate to cancel, so I put that down here. And then for every mole of sodium bicarbonate, how many moles of oxygen are there? There's 3, right? Just using the chemical formula, 3 per 1, right? That's all. And then I want grams, though, of oxygen, so I'm going to use the molar mass of oxygen, right? I want moles to cancel, so I put moles down here. And I put 16 grams up there. Barely had enough room. Grams of NaHCO3 cancels, moles of NaHCO3 cancels, moles of oxygen cancels, leaving us with grams of oxygen, exactly what we want. So plug in your numbers. 5.8 times 1 times 3 times 16 divided by 84.01 divided by 1 divided by 1. And I'm getting 3.31 grams of oxygen, which sounds about right. How many sig figs do we have? We only have 2, so we have 3.3 grams of oxygen. Okay? So again, grams to moles using molar mass, moles to moles using the conversion factor chemical formula, and then moles to grams, molar mass once again, right? I'll do another example. Let's take a look at the next one. Again, asking oxygen. Determine the mass of oxygen in, in a 7.20 gram sample of aluminum sulfate. Okay, so very similar to the problem we just did, actually pretty much the same. So again, grams of oxygen, question mark. What am I going to do? Going to go from grams of aluminum sulfate to moles of aluminum sulfate. Using the molar mass, then using the conversion factor in the chemical formula, moles of aluminum sulfate to moles of oxygen, and then once again, using the molar mass, moles of oxygen to grams of oxygen. All right, so again, starting off, better be careful, I'm going to run out of room. So I'm going from grams to moles, so I want grams to cancel that are going to the denominator. That means moles go into the numerator. Let's calculate that out, again, being careful. Sorry, I have to bring a periodic table, I cannot see the numbers from here. $26.98 times 2, and then be careful, right? There's going to be 3 sulfurs and 12 oxygens, okay? So, plus 3 times sulfur, again, 32.06, plus we have 12 times 16 for oxygen. There's 12 oxygens, right? Hit enter. And I'm getting 342.1 grams. Of aluminum sulfate per 1 mole. Right? Now, so we're going to be here, right? Moles to moles. Again, I want moles of aluminum sulfate to cancel. That goes into the denominator. Put moles of oxygen up here. Again, these are a chemical formula, right? It's 1 to 3 times 4 to 12 moles of oxygen. And then I'm going to use the molar mass to go from moles to grams, right? I want moles of oxygen to cancel. 1 mole of oxygen is 16 grams. Grams of aluminum sulfate cancels. Moles of aluminum sulfate cancels. Moles of oxygen cancels, leaving you with grams of oxygen. Do your math. 7.2 times 1 times 12 times 16 divided by 342.1 divided by 1 divided by 1. And I think I've done something wrong. Hold on 1 second. Oh, no. We're good. Sorry. I thought I was way off. No, we're good. We have 3 sig figs, so I'm getting 4.04 grams of oxygen, which seems reasonable. Start off with 7.20. Okay, again, if you have any questions, you're going to have to email me or look in your book. I hope I explained that so it makes somewhat sense.